Welcome to Eureka Math. I'm Mr. Shankel. Going to be helping you today with Module 4, Lesson 22. Let's get started. Peter paints a wall at a constant rate of 2 square feet per minute. Assume he paints an area y in square feet after x minutes. Express this situation as a linear equation in 2 variables. All right, well, I know that he is working at a constant rate of 2 square feet every 1 minute. And I'm going to set that equal to the amount of square feet, which we said was y, the area, over x. And that's the number of minutes. And then if I use means extremes, this is a throwback to our first lessons. 1 times y is y, equals 2 times x, that's 2x. And that's my equation, y equals 2x. That means I have a y-intercept of 0, right? We wouldn't write plus 0. So I'm going to cross the y-axis at 0. That's 1 point. And then my slope is up to right 1. So up to right 1 would be there. And then we can write the, we can draw in our line that matches that data. And that would be right there. Okay, number 2. Nicole just finished a 5-mile walkathon. First of all, let's go to number 2 here. Number 2, the figure below represents Nathan's constant rate of walking. Well, let's figure out what Nathan's constant rate of walking is. I'm just going to choose a point on the line on an intersection. So that's 1. That would be a distance of 4 miles. 4 miles in 1 hour. 4 miles per hour. So that's Nathan's rate. And then part A, Nicole just finished a 5-mile walkathon. It took her 1.4 hours. Assume she walks at a constant rate. And let's find out what Nicole's constant rate is. Well, we're going to compare that to Nathan's, and that's the slope, right? So the slope would be the coefficient of x. So let's see what happens here with Nicole. I'm still going to do distance. Distance is 5 miles. The slope is equal to 5 miles. And it took her 1.4 hours, 1.4 hours to finish the 5 hours. And we need to write an equation, but we also need to figure out what this actually is. What is her rate? Well, to do that, I just divide. So I'm going to get my calculator out, and I'm going to just find out what 5 divided by 1.4 is. And if I do that, I get 3.57. If I round that, 3.57. So M equals 6 to round it to the 10th place. 3.6 miles every 1 hour. And that's Nicole's rate. And we can see that they're different. Nathan's rate is actually a little faster. But now I want to see what the linear equation would be for Nicole. So I'm gonna use that 3.6 over 1, and I'm going to set that equal to y over x. And that gives me y. 1 times y is y equals 3.6 times x is 3.6 x. And that's the equation for Nicole. If I wanted the equation for Nathan, then I would just come back here to Nathan's rate. I'd set that equal to y over x. And 1 times y is equal to 4 times x, 4x. So there's the 2 equations. Y equals 4x for Nathan. Y equals 3.6x for Nicole. Number 3. Susan can type 4 pages of text in 10 minutes. 4 pages in 10 minutes. That's our rate. Assuming she types at a constant rate, write the linear equation that represents the situation. Well, I'm going to set that to y over x, the number of pages over the number of minutes, and then I'm going to use means extremes and multiply cross products. 10 times y, that gives me 10y, is equal to 4 times x. That gives me 4x. And then I just want y all by itself, so I'm going to multiply by the reciprocal of 10. And I'll do that to both sides to maintain balance. We get y is equal to 1/10 times 4 is 4/10, or if I simplify that, that's 2/5. So y equals 2/5 x is the linear equation for Susan. Okay, and then part B, the table of values below represents the number of pages that Anne can type y in a few selected x minutes. Assume she types at a constant rate. Well, I'm going to do the same thing. I'm going to take the rate, which is y2 over x3, 2/3, and I'm going to set that equal to y over x and means extremes. 3 times y is 3y is equal to 2 times x, that's 2x, and then I'm going to multiply by the reciprocal of 3 to isolate the y. And when I do that, the 3's cancel. I get y is equal to 2 times 1/3 is 2/3 x. So y equals 2/3 x is the linear equation for Anne. Y equals 2/3 x. Who's faster? Well, I can just check these out. I can say, well, what if they both type for 1 minute? If they both type for 1 minute, I'd put a 1 in for x, and I'd get 2/3 times 1. So the number of pages for Anne would be 2/3 of a page. And if I put a 1 in for x for Susan, this would be y equals 2/5 of a page. And then I have to decide 2/3 or 2/5, which one's more. They've both typed for the same amount of time. I just have to figure out which one has done more work. So I'm going to change both these denominators to 15. So I'm going to multiply by 5 over 5. That gives me 10/15 of a page. And then multiply by 3 over 3. That gives me 6/15 of a page. And 10/15 is bigger than 6/15. So Anne is faster. Okay, and the last one for today. Phil can build 3 birdhouses in 5 days. Assume he builds birdhouses at a constant rate. Write a linear equation to represent the situation. Well, 3 birdhouses in 5 days is equal to y over x. And then cross multiply, cross products. 5 times y is 5y is equal to 3 times x. That's 3x. And then I'm going to multiply by reciprocal. So I'm going to multiply by 1/5 to isolate the y. The 5's cancel. I get y equals 3 times 1/5 is 3/5 x. And that is my equation. Y equals 3/5 x. And that's part A. The figure represents Carl's constant rate of building the same kind of birdhouses. Who builds birdhouses faster? Well, 3 birdhouses in 5 minutes, or 5 days, sorry, 3 birdhouses in 5 days is Phil. And then we just look at the slope. So if I start here for Carl, the next line that intersects would be here. So that is an up 3, that's 3 birdhouses in 4 days. 3 birdhouses in 4 days. So this equation is y equals 3/4 x. And 3 in 4 days is faster than 3 in 5 days. Carl is faster. All right, that is lesson 22. I hope that helps. See you again next time.